Hi, welcome to Solving Science. I love it when the universe breaks the established rules because it usually means the rules that we've established are wrong. That leaves the scope for new science, new discoveries, new theories to emerge. And the universe, back on the 27th of May, 2021, so about 4 years ago, was struck by a particle, a single subatomic particle that defied all of the known laws of cosmology and physics. And what we're going to do is understand what we witnessed, what we detected, what we think it might be, how and why we can't explain about this particular phenomena. And then, as I've done before, I'll try and use expanse tension theory to see if that brings any new light to what we witnessed. So I'm going to need my glasses for this one. 27th of May 2021 at the Telescope Array Project in Utah in the USA. There are 500 surface detectors spread over 700 square kilometers of a huge Utah desert. And they detected a particle that scientists have called the Amaterasu Particle. It's the Japanese sun goddess, indicating that there's a very high energy anomaly, some mysterious cosmic bullet which has struck the Earth. So, some big problems with this particle. Firstly, the energy level that was detected, and that energy level has been put at 240 exa-electron volts of energy. That's 2.4 times 10 to the 20 electron volts, which is massive. That's beyond any capability of human machine. It's way beyond the Large Hadron Collider. Nothing humans have got can produce this level of energy. So the problem is there is a limit called the Greisen Zatsepin Kuzmin limit. Let's call it the GZK limit for short. And what it says is that ultra high protons crossing the universe can't pass a certain limit at 5 times 10 to the 19 electron volts because they can't survive the journey across the cosmos. Now, if a particle has passed more than 50 megaparsecs across the cosmos to Earth, then this limit kicks in and says the energy can't be sustained across that vast distance, which is about 160 million light years away. Now, this particle, the Amaterasu particle, strongly appears to have come from further than that distance. So that is a problem. Now, when you look at the impact trajectory and angle, you can work backwards to look at the space where this particle came from, and it appeared to come from the complete empty deep void of nothing. So there's no detectable origin source for where this particle came from. So we've had, I think, the second highest energy subatomic particle hit the Earth in all time, and it appears to have originated from absolutely nowhere. What do we know about it? Well, the highest energy particle was called the Oh My God particle, which hit in 1991. Again, it was also a known void region of space. The indication from those scientists detecting it say it's most likely either a proton or a very light nucleus, probably helium or nitrogen, and it's not an iron nucleus. The anomalies we have then are the energy is far beyond the theoretical limit. The trajectory leads backwards to an empty void of cosmic space. There appears to be no visible radioactive source of any kind of pulsar or binary pulsar or any kind of high energetic phenomenon object in the direction where we look. So we don't understand it. Under general relativity and the standard model of physics, we have no known explanation for this particle reaching us at all. So now, one part of the existing theory is it's either propagated from something that we don't understand in physics. So there's no known physics, there's no known phenomena that can eject a particle at this level of energy. Or the current theory say maybe it was re-energized in transit. Maybe it picked up some energy and acceleration in transit. I like that. We'll come to that point a little bit later. So now to expanse tension theory. What does expanse tension theory have to offer this? Now, I think we've said before, expanse tension theory has something to offer on highly energetic subatomic particles hitting the Earth. So again, a recap. Higgs licensed mass can couple or uncouple to expansion field of the universe. And that in the cosmic void then drives acceleration in that cosmic void. It's our explanation for why gravitational lensing can increase in the cosmic void, as we see in places like the bullet cluster. So we have something to say here. Across the universe, matter forms filaments and clusters where grouping is stronger. And in the vast voids, these filaments and the coupling weakens. So the first mechanism expanse tension theory has to offer this is the void-based acceleration, where high energy particles cross this dense region of ultra-low density interior of a cosmic void. The coupling drops very sharply. The expansion tension becomes unbalanced, and that imparts a net push, converting field tension into kinetic energy. In other words, the void itself can create an acceleration. Rather than slowing it down, it can actually accelerate and promote. Then the particle path through this photon field of the cosmic void. In ETT, the void, the photon energy density and matter both fall, meaning there are fewer collisions and there's lower energy losses, implying that the GZK limit I spoke about earlier actually might vanish as you're going through the deep void corridor of low density space. So this Amaterasu particle could travel enormous distances without losing its original energy. We then have what we've spoken about only a few minutes ago, is gravitational lensing through the void. Now again, in this coupled void dynamics of expansive tension theory, we have the potential bending of gradients and contours through space, which could lead to either like a curvature of space-time lensing or like refractive lenses. The particle's path could have been bent or refracted in so doing so, hiding its actual origin in space, hiding its actual origin, and making it appear that it comes from an empty region of sky. Scientists are not naturally looking for gravitational lensing since they're looking at an empty void of space. But within expansion theory, the empty void of space creates additional lensing. Again, bullet cluster shows additional lensing through the deep void versus against mass and matter. So we've seen that before. We've observed that in other places of the universe. Okay, so we might be misled by the field gradient lens, having no apparent source of this particle. We also then have expanse tension ripples in ETT. Now remember, in space-time, Einstein, space-time is a geometric manifold. There is nothing that can hold or propagate or support energy at all. It's a geometry and a curvature of space. Expanse tension ripples, because there is an underlying field, tiny at local densities, but it becomes vast over megaparsecs and over many billions of years. The energy field of expansion tension ripples could have a potential. The potential here is that the expanse tension ripples can transfer energy from the background field of the universe, and it could potentially have accelerated this particle. The analogy being, it's like a surfer catching a wave. And again, there's a potential that this could have accelerated the Amaterasu particle. So the overlays here, we've got 4 different effects that could combine to leave us with this super high energy particle. We've got void acceleration, we've got reduced scattering of the interacting photons that would be in the cosmic void, bypassing the GZK limit, as we've seen has happened. That's now been observed. We've got void lensing is greater than matter lensing. We've seen that before, and we've got then the potential to explore expanse tension ripples as an additive energy multiplying and expanding the energy. So this particle could arrive at Earth at higher energies than it was emitted from its source, and we could potentially look at this anomalous lensing through the void and actually find a source in a completely different location. So this particle, it hit Earth with phenomenal power, phenomenal energy, 240 exa-electron volts. It's huge. Nothing in general relativity can explain it. Nothing in the standard model of cosmology can explain it. It appears that expansion tension theory has something to offer. Maybe these 4 ideas of expansion tension theory can combine to give us a new way of looking at this is the second highest subatomic particle to strike the Earth from an apparent cosmic void. So it's interesting. Thank you for listening. Thank you for subscribing. If you have a friend who happens to be a world-leading cosmologist or quantum field theory mathematician, I'd love to meet them. Please share the video. Let's get excited about a potential quantum theory of gravity, because that's what expansion tension theory is potentially claiming to be. All right, thank you very much for listening. Bye-bye.